Welcome everybody. No warm-up today. We're just going to go straight to grading our previous homework, which was Cumulative Review 1. We did the problems on the left together. If you weren't here, you can go ahead and grab those from a classmate. No big deal. Those are just notes. But the even problems on the right, you'll need to grade. We'll do 4 at a time. So take a look at these 4, and in a minute we'll shift 4 more problems. All right, next 5. And the last 3 on the first page. All right, flip the page, problems 26 and 28. Problems 30 through 34. All right, last 3, 36, 38, 40. Remember on 36, to really know what the inverse would be for a quadratic, someone would have to restrict the domain to either the positive numbers or the negatives. No one did on this problem, so we show both possible inverses here. We'd actually have to choose one or the other based on a restricted domain if someone had given us one. As we always do, place your score at the top right corner of the first page, divide by 40, times that percentage by 10. This score is out of 10, usually they're out of 5. But this is a double points assignment, so you'll give me a score out of 10 points here. Okay, pause the video here while the students gather their scores, and we'll get back together here in a minute to go through Cumulative Review 2. We'll go through Cumulative Review 2 in the same fashion we went through Cumulative Review 1. I'll do the problem on the left, and you do the problem on the right. Problem 1, we're asked to factor a quadratic expression. And you'll remember the method we used for this is the umbrella method. I drop the middle number into the top of this x, and I multiply the first number, which is a 1, by the -8, and that number goes here. So, all that's left to do is figure out 2 numbers that multiply to give me -8 and add to give me 2. Those numbers are 4 and -2. They multiply to give me -8 and add to give me a +2. Now I just have to use those numbers to write the factors. That's how it's done. X plus 4 and x minus 2. Go ahead and take a minute to give problem 2 a try. Problem 3, we drop the top number in the middle like we always have. You'll notice the number in front of the x is a Ninja 1. You can't see it. The number that goes in the bottom of the x is multiplying the lead coefficient and the constant coefficient together. So 2 and negative 6 make a negative 12. Now we're looking at numbers that multiply to give me negative 12 and add to give me 1. Those numbers would be 4 and negative 3. There's an extra step here because the lead coefficient is equal to 2. We need to divide both the number on the left and the number on the right by the lead coefficient. You'll notice that when I divide the left side by 2, I can reduce. And I do, to 2. However, the fraction on the right does not reduce. So I'm ready to write my factors now. The first factor is simple to write, x plus 2. However, the second factor is a little trickier. The denominator gets multiplied by x, and then we add the top number. Since it's a negative 3, you get 2x minus 3. Take a minute and try problem 4. See if you can do it. For problem 5, we have another situation where we're going to factor, but this time we're asked to solve, to find the roots. So we're going to factor, but then we're going to actually go on to find the solutions. So I've begun the problem already. I dropped the 5, and I put a negative 6 in the bottom. I'm looking for numbers that multiply to give me negative 6, but add to give me a positive 5. Those numbers are 6 and negative 1. All right, I could write those as factors and then set each factor equal to 0, but we've also learned that these numbers are the solutions, except that they're opposite signs. So I can go straight to writing my solutions right now. I'm going to have a negative 6 and a positive 1. Now it's important, guys, to realize that if I ask you to factor, you stop by giving me the two factors, as in problem 3. But if I ask you to find the roots or to solve, you're actually giving me the values where the graph would cross the x-axis. Go ahead and try problem number 6 using the same technique we used in problem 5. Right, I've done a little bit of scratch work while you were working on problem 6. You'll notice in problem 7, 10 was on the right side of the equal sign. It was not on the left side, therefore this wasn't in standard form yet. We can't solve an equation using factoring until we have things in standard form. So now we've got everything on the left. We're good to go ahead with the umbrella method. I moved real estate here because I was a little scrunched there. So over on the right side, I'm using the umbrella method. I'm looking for numbers that multiply to give me negative 20, add to give me positive 1. Well, I'm thinking positive 5 and a negative 4 will do nicely there. But because there's a leading coefficient right here, I've got to divide both sides by that leading coefficient and reduce, if possible, which I can on the right side. So since it's asking me to solve right here, I'm actually looking for the answers. I'm not looking for the factors. Those answers are just the opposites of the numbers on the left and on the right. So negative 5 halves, or you could say a negative 2.5, and a positive 2 will be my solutions. Take a minute to give a shot at problem 8. Remember to get that in standard form before you begin. Problem 9 is another quadratic equation. I can tell because it has an x squared in it. We're asked to solve this time using the method of square roots. So our approach is a little different here. We don't want to be in standard form. We actually want x squared to be alone when we use the method of square roots. So starting here, I need to begin by subtracting 8 from both sides and rewriting my equation. That gives me 2x squared equals negative 8. Now I need to divide both sides by 2. So when I do that, I get x squared equals negative 4. And I think you're all quite aware now that if you want to get rid of a squared, you square root both sides. If I do that, I get x equals, and here's the part that a lot of people still forget, plus or minus square root of negative 4. Well, okay, we know when we get a negative inside of a square root, an I has to be brought to the outside because the square root of negative 1 is I. So we still have a plus or minus here. An I comes to the outside. What's inside is now positive. Now we can look at 4. 4 is the same thing as 2 times 2. It's a perfect square. So I can pull the 2 to the outside, and I end up with plus or minus 2i as my solution. Use those same techniques and solve problem 10. You'll want to write down the quadratic formula somewhere on your paper, probably not where I put it because you need to do problem 12 there. Maybe off to the left margin, somewhere else where you can look at it as a reference. Remember, this formula is a little intimidating looking, but it's actually a really easy technique. You just have to figure out what A, B, and C are and then plug them in. So we're just going to identify A, B, and C here. A is the lead coefficient, the one in front of the x squared. B is what we call the linear coefficient, the one in front of the x. And C is the constant coefficient, or the constant term, rather. Now that we have A, B, and C, we just go to our formula, and everywhere there's an A, we put 1. Wherever there's a B, we put negative 3. And wherever there's a C, we put 5. And I highly recommend putting parentheses around any number that you insert into the equation. So negative, and in the place of B, I'm going to put negative 3. You've got plus or minus. In the place of B again, we put negative 3. A was 1, C was 5. So far, so good. Now, remember when you draw this line here, this fraction line, it needs to go under everything. Okay? Now, we can go through and simplify this a great deal by hand. We can see that the discriminant, all the stuff inside the square root, becomes negative 11. So I'm almost there because I really can't simplify anything besides getting the negative out of that square root. So I bring the I to the outside. The inside becomes positive. You can't factor 11 down anymore. It's prime. And so your solutions are 3 plus or minus I square root of 11 divided by 2. All right, take a little time on problem 12 and try that out. Again, anytime through this video, if you need to pause it, take a little more time, that's okay. You do need to make it through 20 problems, so don't pause too often. I'm trying to give you a little time for each problem. Some of these quadratic ones take a little more time. That might be a good time to pause, but otherwise, probably just need to push forward. Even if you didn't completely finish the problem, at least now you have an example on the left that you can take and use if you don't finish it in class. Okay, I've gone ahead and written this one out. So A, B, and C, I've identified those as 4, 4, and 1. Plug them in their respective places in the equation. You'll notice this time the discriminant is 16 minus 16. It's 0. All of this stuff goes away. So all you're left with is a negative 4 on top and an 8 on the bottom, which reduces to a negative 1/2. A single solution. This must touch the x-axis